The journey from curiosity to insight is what is science. This is not just one statement. The fact is, if you take any discovery, let's say Newton's discovery about gravity, when the apple fell on his head, he started to ask questions. He was curious about why does the apple fall down, and that curiosity led to some kind of insight for Newton. And that is what we study or teach in science as far as the gravity is concerned. Science is nothing but a journey of a human being from curiosity towards some kind of understanding. This is exactly what is the theme of this project today. The project starts with a question based on curiosity. Let's walk through this. The question is, why is this sound button called volume? Now, should we have a remote control on our hands and then we'll press the button to increase the volume? What is volume? We are basically saying that we want to increase the sound level. But we don't call it sound, we call it volume. Why? That's the question. Why do we call it volume? It's sound, but we do not increase the volume of the television because the volume of the television will make it fatter. The television will not have greater volume now. But as the sound button, we press the volume, the sound level increases. So why is this not called a sound? Why is this called a volume? Before we answer this question, we have to understand this, that when we are increasing the sound level, we are basically saying that we want to amplify the sound. And the sound amplification takes place because of the devices of related to electricity as well as magnetism. There is an amplifier built in all these kind of devices, may it be television, may it be speaker. This entire thing based on electricity. But when the electricity was not invented, how was amplification possible? Or was there no amplification of sound? We will see that today. And I'll show you using this small experiment. This is called as a resonance tube. Why is this called as a resonance tube? We'll discuss that. But first see this. If I have this tuning fork vibrating and I take it close to my ears, I hear the sound of the tuning fork vibrations. I hear the sound. But if I just vibrate the tuning fork here, I feel the vibration in my hand, but I do not hear the sound that clearly. But if I hold it here, the sound is heard. Why is the sound heard here? The same tuning fork producing the same kind of vibration is suddenly loudly audible here. It wasn't audible when it is like this. This happens because this air column inside this tube is the air, and we call it air column. The entire air column vibrates with this frequency. Now the air column would be vibrating when I hold it like this, but we don't hear any sound here. Why? Because the length of the air column is far too much. If the length is reduced at certain length, you can try different length at certain length, there is a perfect match and the resonance is taking place. When the frequency of vibration of this air column perfectly matches with the frequency of this tuning fork, resonance will take place. And when the resonance takes place, that is when a loud sound is heard. This tube is called as a resonance tube because inside this tube, the air column happens to have a resonance with this vibrating tuning fork. And the result is, you hear the vibrating sound. A loud note is heard. So this is what resonance tube is. It shows us the ancient way of amplifying the sound. The amplification of sound happens through resonance. When the frequency of the vibration perfectly matches with the frequency of the fundamental frequency of the air, and the entire air column vibrates and a loud sound is produced. You can take the example of tabla or even string instruments like sitar, guitar. Let's take this instrument. This is a sonometer. We'll discuss about resonance and music, how resonance helps in music. I have a paper writer here, and this paper writer, this very tiny paper rider is made to sit on the wire. So I have the paper rider ready, and I only use the tuning fork. At a certain distance between the tuning forks, this entire length of vibration, this length of wire will vibrate with its own frequency of its own choice. If this length is more, the frequency of vibration will decrease. If the length is less, the frequency will increase. Now what has happened is, for this tuning fork, I have found a perfect match. At a certain length, the frequency of vibration of this wire is equal to the frequency of vibration of the tuning fork. And when both the frequencies perfectly match, there is resonance and a loud vibration, large vibration takes place. And when the vibration is large, the paper rider falls off. And when this paper rider falls off, we understand that there is resonance. Why would the paper rider fall off? Because obviously, should we have this kind of a wire, a straight line wire, then when the resonance takes place, there is a loop formed here. And when this loop is formed, the vibration is maximum. The paper rider also vibrates with maximum amplitude, and because of inertia, it is dislodged. When it is at the topmost point, the wire comes down, the paper rider is thrown out. This entire thing is based on resonance. This is how the resonance and musical instruments work together. This is a box. There is a hollow box inside this sonometer. Whenever I place that vibrating tuning fork close to this, you hear this sound. This is because of the vibration, and the entire vibration is passing through this sonometer box as well. The entire air will vibrate, the string will vibrate with the same frequency, and the resonance will take place. Should we take the example of a tabla? There is an air column which will vibrate because of the percussions of the leather. If the leather is struck, the leather will have percussions, it will have vibrations. The same vibrations, with the same vibration, with the same frequency, the entire air column inside the tabla box will also vibrate. And the resonance takes place, a loud sound is heard. The musical instruments are all based on resonance. The strings of music is here. So I have this guitar. I unfortunately broke one string of it. Hopefully I will not break any more. So I'm just striking this string. Should we call this to be sa? Sa, sa. Then re, 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 ga, 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 ma. How is this transition from sa to re to dha to re is happening here? It is happening because I am only changing the place where I pluck the fretboard. This is the bridge of the guitar, and this is the higher bridge. In between that, there is a fret. This is the first fret, second fret, third fret, and so on. When I place my finger here, the effective length is not this much. The length reduces to this point, up to the first fret, slightly reduced. When the length reduces, frequency increases, and a larger note is heard. So from sa, we hear re. See this? First is sa, 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 re, re, re. Ma, ma. the frequency increases. This is how the entire fretboard is designed. The entire fretboard is designed to produce vibrations of the string, and with the decrease in the length, the vibration of the string will produce different frequencies, and we hear different sounds, different source. Why this hollow box? The hollow box is to produce resonance. The only vibrating wire was here as well. It wasn't producing such a large sound, loud sound. This wasn't producing that kind of sound. So why this sound is loud? Because there is a bigger air column here. Bigger the air column, bigger will be the vibration. And this is exactly what we want to know. We started with a question about what is the relationship between sound and volume. We are very close to that. Now I'll show you with the same experiment again of resonance tube. Let's see this. The first tube I'm taking, I hear sound. And now I'll take a larger tube. The length will be same because for the same frequency, the length above the water column will remain the same, vibrating length. But this is producing a larger sound, much larger sound. Why is this sound larger? Why is this louder? It is louder because the volume is greater. This tube, its diameter is greater. Although this length was same for both the tubes, this diameter was larger, and because this diameter is larger, area is more and total volume is more. If the volume increases of the device, then more air columns are there to vibrate. And if these vibrations are more, then we hear the greater sound. You can compare this with this one. This is like a lead singer of a band, alone singing. Few people can hear this, like I could hear it when it is placed here. But others cannot hear. This will make sure that there is a huge set of chorus here. A lot of people, a lot of air molecules singing the same tune. As a result of that, a large vibration is produced. So what happens is when the volume of the device is increased, the sound loudness, sound level is also increased. Anciently we used to have tabla which will be audible to a small room. Then we will have a dhol which will be audible to 2, 3, 4 different rooms together. But if we have a nagada, a huge kind of percussion device, then the entire small village will hear the sound of the nagada. The audibility increases because the volume of the device is greater. And if the volume is greater, then in those days, anciently, if someone is saying, yeah, the sound audibility is less, it is not loud enough, then his master will tell him, his guru will tell him, just take a new device and increase the volume. We are not changing the device in this age. We are having the same television. But the label is still there. The same words are still there. If you cannot hear the sound of a television, we say, increase the volume. We started with a question. We come to the answer of this question. But in between this journey, we understood about resonance, we understood about resonance tube, we understood about the sonometer, and we most importantly understood about how a guitar was designed. That's how the learning is, and that's how we learn. You can start with a curious question, and by the time we reach the answer of this question, our enrichment of learning, enrichment of knowledge, and our enrichment of experience as such has already taken place. I hope you like this. Thank you.